Hello, my dear students. How are you all? Okay, so in the last session, we discussed about a few parameters of electricity chapter. Good evening, everyone. Good evening. Thank you so much. So, in this chapter, we will be talking about further next, and we will be starting with electric circuits. My voice is clear, no? My voice is audible. Hi Sanjeev, hi Selva. Okay, so initially, whenever we are talking about electricity, especially in the class 9th or 10th syllabus, it becomes very relevant for all of us to understand what electric circuits are. Because the quantities which we were talking, resistance, current, voltage, potential difference, these quantities are like the properties, and the properties will be implied on some circuits or some parameters. So these are those parameters which we have discussed over here. Initially you can see, okay, thank you so much. So initially you can see that there is a cell. The group of cell or multiple cells, when they are plugged in together in series format, that thing is known as battery. There are wires in which the current will flow, the exact charges will be flowing through them. This is known as a joint. This is known as a cross section without any contact. This is a fixed resistance. Why we have stated that this is fixed resistance? Because this type of resistance or a resistor will not be changed, and there is a device, you will be seeing that device maybe when you will be in your college, or I think maybe in 11th class also in physics lab. That device is known as rheostat or a variable resistance device. So next thing is somewhat this. These are symbols. These devices won't be looking exactly like their symbols, but whenever we will be speaking about these devices or these circuits, these are the exact symbols in which we will have to denote these devices. Next is ammeter. We will be coming back to this in the next slides. Voltmeter and galvanometer. Three types of meters are there. Open switch. The purpose of open switch is stating that whenever there is an open circuit, I mean there won't be any current flowing through that. So that sort of, there is a switch or a plug key. That thing is known as open switch. For example, if the fan is not on, it is in the off position, so that thing is known as open switch. The counterpart is known as closed switch. Good evening, Shreya. And the electric bulb is just an appliance. There could be other appliances also, we would be seeing in different numericals. So these are the basic components of electric circuits, the minute components of that. When we arrange these components in the form of this diagram, so there is a light bulb, there is a switch, the current is flowing in this direction, there is a group of batteries, we will be there is a group of cells, I mean, and together they will be known as battery, and there is a resistor. So together these things will be known as entire electric circuit. This is original circuit. By original I mean that this is the physical form of a circuit, I mean these devices are there, and this is what the proposed, or how we write in our notebooks or in books, this is somewhat related to that. A similar circuit is also represented over here. It contains more components, like there is a resistor. This resistor, it is denoted by R. We know that resistance is calculated in ohms, and parallel to this resistor there is a voltmeter. So as the name is suggesting, voltmeter would be there to identify the voltage in that circuit or voltage in that resistor for that part. Now in series connected to this resistance, there is a device which will be calculating the current, and this device is known as ammeter. We know that the current is calculated in SI unit of current is ampere, and similar is the name with ammeter. So these are related in that sense. Now there is a switch and there are cells or batteries, and these are connecting wires. Now coming to the next part, which is even more important than this for numerical purposes as well. So we need to identify the plus and minus things also. For example, we know that in the cell there are two terminals. We have already spoken about this in the last session, wherein the flow of charge was maintained by a potential difference. So in a cell there are two terminals, one terminal is positive and one terminal is negative. If we look into this, so we can find that this is the positive terminal and this is the negative terminal. And if you assume the current of the flow of current is from positive terminal to the negative terminal, these are the direction of current. This is the very first thing which we have to check in an electric circuit. The question directly comes to us, in which a circuit is given to us and it is being asked that whether the circuit is correct. If it is incorrect, so we have to identify which component or which particular part of that circuit is incorrect, and we have to correct that thing. Now this was the first thing, the flow of electric current. Secondly, we would be talking about the positive and negative terminals of the ammeter also. So how do we need to check this thing? If this is an electric cell, always the larger component of the cell will be positive and smaller will be negative. And when there is an ammeter connected to it, so if just this is the circuit, so what will happen, the positive terminal of the battery will be connected to the positive terminal of the ammeter, and similar is will be the case with voltmeter as well, and the negative terminal of the battery will be connected to the negative terminal of ammeter. This will be the connection. Now if we can see that here is the positive terminal and here is positive terminal of ammeter, and similarly here is the positive terminal of voltmeter. So I think the very basic concept has been cleared. Just we need to find it out that the components cell is connected properly, the switch is connected properly, the flow of current we have to calculate, we have to understand that exact flow of current is maintained. And after that, one more thing, we need to identify the positive terminals of ammeter and voltmeter are maintained in respective to the cell or a battery. And similarly, ammeter should always be connected in series to the resistor, and voltmeter should be connected in parallel to the resistor, of which we have to identify the voltage. So can we move to the next part? These are the basics of components. So now this is we have already spoken about this thing, that ammeter is an instrument which is measuring the current. So for measuring current we need an instrument. That instrument is known as ammeter. This is the real picture of ammeter, and this is how we generally would be seeing this in our books. And this is the connection of ammeter, and it is always in series to the conductor. Now question sometimes this 1 mark question comes, that why do we need ammeter to be connected to, why is it always connected in series, and what would be the resistance of that ammeter? Would that resistance would be large value or a low value? So the value of the resistance of ammeter should be very low or near to the negligible value. Why is it so? Why is it so? Yes, can someone please let me know, why do we need the value of ammeter to be very low resistance? Okay, So the low value is denoting that that ammeter device is not putting any wastage of electric current in that circuit. That is why no changes maintained due to this ammeter. That is why the value is kept to be very low. Okay, thank you so much, Sanjeev. Okay, so second device which is used for measuring the potential difference. We will be talking about potential difference also. So that is known as voltmeter, and voltmeter is always connected in parallel. We have already seen that, and these type of voltmeters were used previously. Now new devices have came, and we know the value of voltmeter is very high. Why is it very high? So that there is no current flowing through that voltmeter. All the current should be flowing through conductor. This is what the concept of our electric circuit is, and it should also take negligible value of current. So now we understood many things about these voltmeters and ammeters. First of all, we understood that ammeter should always be connected in series, and voltmeter should always be connected in parallel to the resistor. Voltmeter has high resistance, remarkably very high resistance, and ammeter has remarkably negligible resistance. Now there is another device. This is not in your syllabus, but this device, galvanometer, is generally used to identify that there is some current in that circuit or not. And there are also many applications for galvanometer, but currently we would be just accepting this value of this. So now moving on to the first numerical. The question is very simple. A cell, resistor, key and ammeter are all arranged as shown in these diagrams. The current recorded in the ammeter will be, we have to identify the value of current. Thank you so much, Selva. Thank you, Dilip. First of all, do check all the connections. Do check if the positive terminals are connected properly. Thank you, Sanjeev. Thank you, Techie. Techie, what's your real name? Yes, Alva, I got your answer. Okay, so let us see. Let us check the, most of the answers are D. I mean all the answers are D actually. So here the negative terminal is connected to negative terminal, positive to positive. Okay, simple. Similar is the case with this. Similar is the case with this also. So correct answer would be D. Yes, all the answers are absolutely correct. Now moving on to the second diagram, almost a similar question. Here what we are supposed to find out, that all the connections are made properly or not. Is it better now, Sanjeev? Okay, so one answer have been provided to me. Option number 4. Let's see. Thank you, Techie. Thank you, Selva. Thank you, Sanjeev. Thank you, Dilip. Okay, everyone is saying that answer 4 or option 4 is correct. Guys, can I make a request here? Can you please just once again look into all the options and come up with another answer if that is there, because answer 4 is not correct. Kindly please look again into all the options. Okay, so we will be performing this question with the help of elimination method. First of all, let us find that in which components, in which of these circuits ammeter and voltmeter are not connected properly. Okay, so Selva has changed her answer. So we know that voltmeter is always connected in parallel to the resistor, but here it is connected in series to the resistor. So this is not correct. Okay, let us move to the second one. Here the voltmeter is connected parallel to the resistor and ammeter is connected in the series. Okay, this might be correct. We are just leaving it aside. Now moving on to the third. In this, ammeter is connected in parallel to the resistor and voltmeter is connected in series. and we know that is incorrect, that is not the case. So this is also incorrect. In the fourth circuit, the voltmeter and ammeter connections are absolutely fine. Now we are left with just two options. Now we will be checking with whether the positive terminals of the battery are connected with the positive terminals of these devices, ammeter and voltmeter, or not. I am checking it. First I will be checking for the circuit number 4. Here this is the positive terminal of battery, and this is connected to the positive terminal of voltmeter, which is absolutely correct. And similarly, negative terminal of the battery is connected to the negative terminal of voltmeter. So voltmeter connection is absolutely correct for option number 4. Now checking for the ammeter connection. Here the negative terminal of the battery is connected to the positive terminal of ammeter. So this is wrong. This is not correct. Now checking for the second option. Here the things are absolutely fine. Positive terminal of battery is connected to positive terminal of voltmeter, and similarly it is connected to positive terminal of ammeter, and similar is the case with negative terminals also. So what my point is, all of you have made this mistake in a very easy question. So please, we have to keep this thing in mind whenever we are performing these questions, because silly mistakes are not at all allowed in your examinations. So this was the silly mistake number 1. We are moving to the next question. Almost a similar question. Here a representation of series combination of cells to form a battery is provided, and we need to identify which formation is correct and which are incorrect. Again, this question also, whenever MCQ questions will be provided to you, we will try to perform those questions with the help of elimination method, or whenever we are very absolutely confident about the correct answer, then we will be lying on that thing. So these are the options. I am waiting for your answers. Okay, so I've got my first answer from Dilip. Dilip is saying that option 3 is correct. Okay, Selva is suggesting that option 1 is correct. Same is the answer for Sanjeev. Dilip, your friends are not agreeing with you. Do you want to change your answer also? Or maybe Dilip could be correct. By the way, these questions are almost asked in most of your examinations. These questions are very important questions, and most students just neglect these questions and don't prepare for these. Okay, so we are performing this question now. So the terminals of battery, how they are connected. Like this is the positive terminal and this is negative terminal. This is a cell, a single cell. Whenever we are performing, whenever we are connecting multiple cells, so the connection should always be in series, and this is how series connection would be there. A positive terminal, a negative terminal, then the negative terminal is again connected to a positive terminal, then there is negative terminal. This is a battery of 2 cells. Now again this negative terminal is connected to a positive terminal, and again there is negative terminal. So this is how a battery should be there. So this connection is wrong, this connection is wrong, this connection is also wrong. Why? Because negative terminal and negative terminal cannot be connected in a battery. This connection is absolutely right. So option 1 is correct. Now moving on to the next question. The question is, a child has drawn the electric circuit to study Ohm's law as shown in figure. His teacher told that the circuit diagrams, this circuit diagram needs some correction. So we need to identify what sort of connections are incorrect in this circuit and what corrections are required. Question is very much clear to us. We will check whether all the terminals are accurate or not, all the circuit symbols are connected properly or not. This question will be of 3 marks. First of all, you need to identify what connections or what sort of imperfections are there in this circuit, and in the second part you have to correct and redraw this diagram with the correct corrections, with the correct connections. Okay, Selva. How many imperfections are here? Thank you, Vidoshi. Okay, so let's find out what are the problems with this circuit. We know that the current will always be coming out from a positive terminal of battery, but here the negative terminal of the battery, the current is coming out from the negative terminal of the battery. This is wrong, and this is also wrong. Secondly, the connection of ammeter is not correct, because we know that ammeter is always connected in series to the resistor, and similarly voltmeter should always be connected in parallel to the resistor. So what would be the correct? Okay, Sanjeev is stating ammeter is yes, absolutely. So let us make this correct. Initially what we can do, we can make the circuit negative terminal here, positive terminal, negative terminal, positive. So this might be our battery, and this would be this is your resistor. Here is ammeter connected to it, and here is the other thing, and here is voltmeter connected, and here we have this switch. Now initially let us find the direction of flow of the current. So this would be the direction of flow of current. You're with me? And as this is the positive terminal, so this would be the positive terminal, this would be the positive terminal, and these will be the negative terminals. So this would be the correct diagram for this. Now moving on to the next concept. I am hoping that all the circuit diagrams, all the problems related to it, all the numericals which are associated with this very concept are absolutely clear to all of us. So we are good to go to the next concept. Electric potential. Most of you must have heard about the voltage. Voltage is used in most of the aspects, but electric potential is something that if a small positive test charge is placed in an electric field of another positive charge, so it experiences a force. We know that positive charges, if two positive charges are there, so they will be repelling each other, so there will be force of repulsion, and the work done to move that unit charge which has been provided over here in that electric field to the infinity or to a farthest point, so that work done is known as electric potential. We need to just identify this much about electric potential. Next concept on which most numericals would be asked is about the potential difference. Although potential difference is not exactly voltage, but I have written over here that potential difference is generally up to class 10th it is used as voltage also. So what exactly the definition of electric potential is, potential difference is, it is the difference in electric potentials between 2 points. It is a difference between electric potential between the 2 points. So we can understand this with the help of this diagram. Here what we can see that in the initial diagram that two tanks. Okay Sanjeev, let me just finish this concept, then I will be moving on to the electric potential slide again. So here two diagrams, if you can also perform this at your homes as well. So what can happen if two tanks are maintained with the same amount of water, then there will be no flow of water, zero flow of water. But when there is an increase in water in a tank A, so the natural flow of water would be from tank A, which is at the higher potential, to tank B, which is at the lower potential. So whenever there is potential difference, whether that difference is in the water, whether that difference is in the voltage, so there will be a natural flow of something In the case of water, it will be water only, and in the case of voltage, it will be the charges. So this will be happening when there is potential difference. Are you guys with me? And the potential difference is calculated with the help of very simple formula, that it is the work done upon amount of or the quantity of charge which is moved. So this formula would be used in most numericals. So V is equal to W over Q. We know that V, the SI unit of V is volts, and SI unit of work done is joules. It is written as capital J, and Q we already know, it is coulombs. Are you guys with me? So please, if you have to take screenshot of this electric potential, you can take. Shall I move to the next slide? Okay, so now understanding this analogy of water, which I have already shared with you, we can assume that water is compared. You guys know analogies, na? Okay, so water is compared to current and voltage is compared to pressure. So whenever there is net flow of current or flow of water, what is voltage exactly doing? Voltage is pushing that thing. Pressure, what is pressure doing? Pressure is pushing the water. Similarly, what voltage is doing? Voltage is also pushing that current. And what is the work of resistance over here? You know the valve in a tap. So that is blocking the water to come out. That is the purpose of voltage. That's the purpose of valve. Similarly, our resistance is also opposing the flow of current. Three things are there. Water is acting as current, and voltage, we are putting the analogy related to pressure, and valve or a resistance or an obstacle, it is like acting like a resistance. So this is what water analogy in terms of your Ohm's law. Yes, Sanjeev, this is like a comparative thing. Example sort of thing. Okay, now very quick numerical, very easy numerical. How much energy is given to each coulomb of charge passing through a 6-volt battery? We have to identify this. No, Sanjeev, please don't say that. So we have to identify how much energy is given to each coulomb of charge passing through a 6-volt battery. Okay, thank you, Sanjeev. 6 joules. So you would be surprised that, sir, we were talking about the potential difference and we were talking about the work done, and now suddenly out of nowhere you have given us energy and 6-volt battery. So how are we? All the answers are correct, but let me just clarify this thing also. So energy is related to the work done also. We know that SI unit of both energies and work done are similar. More about this I will be speaking when we will be working on the commercial values of electric power. In those numericals I will be stating on this point further. Now 6-volt battery, we know that there is a potential difference in a battery, so that is 6 volt. So with 6-volt battery, it is self-explanatory that we are talking about the potential difference. Now putting these values together, potential difference is already given to us, work done we need to find out, and charge is 1 coulomb. So work done will be 6 joules. All of you are absolutely correct. Now talking about this property, resistance, because we will be talking about coming to the Ohm's law in the next slides. So resistance is something which is opposing the flow of electric current. Anything resistance, resist is something, resist is an English word which is used to oppose something, and in electrical resistance the meaning is to oppose the flow of electric current. Do you guys like my diagrams and these animations which I prepared for you? So this is a circuit, the pipeline, and here are different electrons which are moving, and ultimately which will be known as electric current. And what is resistance doing? Resistance is making these flow of electron to slow down, or opposing the flow of electrons. And this is what the resistance will be doing. Okay, thank you so much. Thank you so much. I will try to put everything, most of the things in form of these diagrams or animations, because I think when visualization is also there, so the concept is very much clear. So resistance is also known to us. Now coming to a very, very important law, and that law is known as Ohm's law. Initially we will be understanding this diagram, then we will be reading about what exactly is Ohm's law. This is voltage, the yellow voltage, and this is our current, and this is the resistance, or the villain of this movie. So what is resistance doing? Resistance is, voltage is pushing the current to pass on. We already know, please remember that thing when the flow of electrons or flow of charges diagram I have provided you. In that diagram, whenever there was potential difference maintained with the help of cell or a battery, so what was happening? It was aligning the electrons to flow in a single direction. So what is voltage performing over here? It is pushing the current. And what is resistance doing over here? It is opposing the flow of electrons. Very important diagram. I think you all can just take a screenshot of this diagram. Very important diagram. Now coming to a very simple definition. At constant temperature, the current flowing through a conductor is directly proportional to potential difference across its ends. What is this definition all about? That V is directly proportional to I. And when we will be removing the proportionality constant, it will be R. R will be acting as a constant, and here this R is our resistance. So the formula will become V is equal to IR. Now this formula, shall I move to the next slide? There could be different annotations of this formula. If we have to find out voltage, this is by the way, this is known as Ohm's law triangle, a very important property. If we have to find it out, find the value of voltage, then voltage will be I into R. We already know V is equal to IR. If we have to find out the value of current, then current will be, we can move the value of R to the left hand side. So I will be V over R. Similar will be the case for resistance as well. R will be V over I. So are you guys ready for next so many questions? Shall we start? And can we extend this class for 5-10 minutes so that all the numericals have been completed at least for this very concept? Okay, so question number 1. Potential difference between 2 points of a wire carrying 2 ampere current is 0.1 volt. Calculate the resistance between these points. Very simple question. Very simple question. Thank you so much, guys. So potential difference is given to us, current is given to us. Simply we have to identify the resistance. Thank you, Sanjeev. Thank you, Vidushi. Guys, one thing you have to follow whenever we are providing an answer, so that answer should always be coming with the SI unit. Otherwise, it would be just half correct. And let us make this as a positive habit also. So, current is provided to us as 2 amperes. And voltage is provided to us as 0.1 volt. We need to find the value of resistance. So the answer is 0.05 ohms. Thank you, Madhu. Thank you, Selva. Thank you, Vidushi. Thank you, Sanjeev. Okay, so let's move to the next question. A simple electric circuit with a 24 volt battery and resistor of 60 ohms, it has been provided to us. So what will be the value of current in the circuit? And they have already stated that the resistance of the connected wires is negligible. So we are not gonna think about the resistance of these wires. Sanjeev, Vidushi and Selva, all three are stating that 0.4 ampere is the correct answer. Let us see. We already know the formula. V is equal to IR, and the value of V is already given to us 24. I we have to find out 60 ohms is the value of R. So I will become 24 over 60, and that will come out to be 0.4 amperes. Yes, all the answers are correct. Moving on to the next part. An electric iron draws a current of 3.4 amperes. This question is important. This question is very important. An electric iron draws a current of 3.4 amperes from 220 volt supply line. What current will this electric iron draw when connected to a 110 supply line? Yes, Dilip, your answer is correct. Thank you, Madhu and Vidushi. Thank you, Selva. Thank you, Sanjeev. Okay, so thank you, Sanjeev. So the answer is we need to identify, first of all, there are two cases, case 1 and case 2. In these type of questions, initially we have to identify what is the common factor between both the cases. So the common factor is electric iron, and we know that resistance of a single device is always remaining to be the constant or a same value. So from these values we have understood that R will be same for both the cases. So what is the value of R? R is equal to V over I, है ना? In first case, so R values would be somewhat related to this. R would be equal to V1 over V1 over I1, and this will also be equal to V2 over I2. Are you guys with me? So the value of R will be constant and it will be divided amongst these values. V1 is for the case 1 and V2 is for the case 2. Now putting these values together, what is the value of V1? It is 220 volts. What is the value of I1? 3.4 amperes. What is the value of V2? It is connected to a supply line of a 110 volt supply. And what will be the value of I2? This we have to identify. So solving these equations, I2 will become 1.7 ampere, and most of the answers are absolutely correct. Vidushi, this answer is not correct. Your initial answer was correct. Okay, you have first of all, I think you guys have identified the value of R, then you have used that value to substitute in the case 2. Guys, this is a very fast method which I have provided over here. We can use this method only because this will be very quick and there are very less chances of making mistakes. Okay, so now moving to the next part. There are different factors which are affecting the resistance in a conductor: length of the conductor, area of cross section of the conductor, nature of the material which has been used, and temperature of the conductor. So this question is sometimes asked in your examinations. Directly it has not been asked in I think over last 7-8 years, but indirectly there are many applications of this question, those will be asked. Now coming to a property of resistance which is known as resistivity. So resistance of a given conductor is directly proportional to length. R is directly proportional to length and R is inversely proportional to area of cross section. When we will be solving these values, so it will become, the resistance will be equal to rho multiplied by L over area of cross section. And what is rho over here? This is your resistivity. There are so many numericals which are asked from this very concept, and one more thing is also asked: what is the unit of resistivity? So how can we identify this unit? We already know that resistance is ohm and area is meter square and length is meter. So this meter will be cancelled with this. So finally the value will come ohm meter. Okay. So please write these formulas in your notebook because we will be having many questions from these. So the question number 1, a copper wire of length 2 meter and area of cross section 1.7 into 10 raised to power minus 6 meter square has a resistance of 2 into 10 raised to power minus 2 ohms. We have to find the value of resistivity. Three values are already given to us and we need to identify the value of fourth. Okay, so two answers have been provided to me. Guys, we have to find the value of resistivity. So it will always be ohm meter. Okay, so let us start with this question. We have to identify the value of resistivity, that is rho, and the formula is rho is equal to resistance into area over length. I've just substituted these values. Now putting these values together, resistance is given to us as 2 into 10 raised to power minus 2 ohms, and length is given to us 2 meters. What is the value of area? Area is given to us as 1.7 into 10 raised to power minus 6, and the value of length is 2 meters. So calculating these values together, it will become 1.7 into 10 raised to power minus 8 ohms meter. I think this was very simple question, no? Sanjeev, how come this value? This was a simple question, right? Okay, now moving to a next question, and this question is also from your NCERT book. A copper wire with a diameter is given to us, resistivity is given to us. First part, we have to find the length of this wire for a resistance. Sanjeev, this will also be incorrect, the answer which you have provided. So copper wire is given to us which has a diameter, resistivity and resistance. We have to identify the length of this wire. Okay, no worries, Sanjeev. Start with a new question. Sanjeev, this the last answer is also not correct. Correct answer is 1.7 into 10 raised to minus 8. I think there would be some calculation mistake. Okay, no problem. Skip that question. Now perform this question which is on your slide. Kindly perform just first part of this question. Second part is your homework. Okay, so in the question they have given to us the diameter of 0.5 millimeter. There are a few things which need to be very clear. We know that value of area is calculated as pi r square. R is radius over here, and diameter is equal to, or the radius is equal to diameter over 2. So that will become 0.25 millimeter. Once again, we need to find the value of, we need to convert this value into meters. So it will become 0.25 into 10 raised to the minus 3 meters. Now putting this value in your area formula, so it will become 22 over 7, the value of pi, and radius is 0.25 into 10 raised to the minus 3 square. Now putting these values together, so after solving, this will become somewhat related to 0.2 into 10 raised to the minus 6 meter square. This will be the value of your area. Now putting these values together, we have to find the value of length. So formula is rho is equal to R into A over L, and the value of L would be R into A over rho. So resistance is 10 ohms, area is 0.2 into 10 raised to the minus 6, and the value of resistivity is 1.6 into 10 raised to the minus 8. So after solving, this will come out to be, yes, most of your answers are correct. It will come out to be near to 123 meters. This will be the outcome of this value. So we have performed the answer number A. Option B is your homework, and you can check this question in your NCERT book as well. Now moving on to a next question. This will be the last question for the day. A 6 ohm resistance wire is doubled up by folding. There was a wire and the resistance of that wire was 6 ohm and it is doubled. Now we are required to find the value of new resistance of this wire. These are very important questions from the point of view of your 1 marks question, or they play a vital role in even 5 marks questions as well, because they are based on the concepts. A wire was there and after folding it, we have to identify the value of new resistance. Yes, Sanjeev, this is correct answer. Thank you, Vidushi. This is also correct. So let us understand the concept behind these questions. We know the value of R is equal to rho L over A. And this is the formula. Now understanding the concept over here. There was a wire. This was case 1 and it was having a resistance of R value. And what happened to this wire? This was folded. And after folding, we need to identify the value of R dash, the new resistance. So what will happen to this wire? First thing, the new length will be L over 2. That will be the very first thing. And what will happen to the new area? It will become twice of the previous area, because after folding the cross section will be doubled. Now putting these values together, R dash we have to identify. Rho will already be the same, so we are ignoring that value and just putting the value of L dash over A dash. So L dash will become L over 2 and A dash value will become 2A. So the value will come out to be L over A, or we can also write it rho, we can also write upon 4. Now substituting the values 1 over 4 rho L by A. So we already know the value of rho L by A is equal to the previous resistance, the old resistance. So now putting here the old resistance value. So new resistance will come out to be 1 by 4th of the value of the older resistance, and your answer will be 6 by 4, that is equal to 1.5 ohms. So guys, these were a few examples or a few concepts which we discussed, and in the next class we will be coming up with more questions, especially from series and parallel circuit connections. We might be touching the concept of electric power as well. So let us just have a recap of the session, entire session. So initially we started with the electric circuits. We identified what are the correct connections, how the terminals of battery are connected to be with ammeters and voltmeters. Then we understood about ammeter, voltmeter and galvanometer. We performed a few examples. We understood the concept of electric potential, and also we understood the potential difference. Water analogy, we have discussed that water is compared to current and pressure is compared to voltage. Few numericals. Then we have also understood the concept of resistance. Whenever resistance will come, we shall understood that it is something which is opposing the flow of charges or current. Then this is Ohm's law. So resistance is opposing and voltage is pushing, and current is the one which is flowing in that direction. Now with the help of these few examples, we have understood the concept. We have also touched resistivity and different numericals based on that. So thank you so much guys, and for the next session what we can do, we can call upon our friends as well. As many friends we can call, and let us make understanding the concepts of science together and achieve the success which is definitely required to us and desired to us. So thank you so much and all the best to your endeavors. Take care.